We are consuming energy all the time. No matter what you are doing, driving, walking, even sleeping, you are consuming energy. The most enormous energy source we rely on is our nearest star, the sun, and we have been using this solar energy for a long time. Familiar sources of energy, like wood, coal, and petroleum, are all solar energy stored in different forms on our planet. But now, we have found that these fossil energy sources are giving rise to pollution and causing global warming. So one solution is to use the energy directly from the sun. People have created solar cells to convert solar energy to electricity so that we can power the devices in our daily lives. How does the solar cell work? If you buy a solar cell, it appears to be only a piece of solid blue panel. But let's zoom in and look at its details. The solar cell is actually built like a sandwich. For example, let's take a look at a 3-layer solar cell. The layer in the middle is the key material that converts light to electricity. When light enters this material, it is possible to generate free-moving electrons and the vacancies they leave behind, known as holes, which carry the opposite charges and will flow to the outside 2 layers. These 2 layers are electrodes that can be wired to a light bulb. The flow of electrons and holes creates the electric current needed to power the light bulb in this circuit. Sometimes it is hard to harvest electrons from the middle layer and move them to the electrode layer, so engineers add 2 additional layers to help transport the electrons and holes to the electrodes. In this way, the solar cell becomes a 5-layer sandwich, which is the more common structure. Now, you can see that the main mechanism for solar cells is generating and harvesting electrons and holes that can freely move around. However, a harvesting problem occurs when an electron and a hole meet. They combine, or in other words, an electron fills a hole, and they can no longer move freely. This prevents harvesting and their contribution to the electric power output. When this happens hundreds of thousands of times, a great amount of energy is lost. This problem only happens in the middle layer when electrons and holes are moving to their appropriate electrodes while traveling in opposite directions. They become safe from combination after arriving at their harvesting layer because they are in the presence of only fellow electrons or holes. If the middle layer is thinner, electrons and holes have less possibility of meeting. So we can reduce the harvesting problem using a thin middle layer, thereby creating a thin film solar cell. But it doesn't mean the thinner the layer, the better. If the layer becomes extremely thin, light cannot generate many electrons and holes within such a short length. So a generation problem occurs when the middle layer is too thin. Based on our research, we find that using a photonic crystal is an approach that can increase generation in thin film solar cells. The original layers of a solar cell are planar. Now, we dig some actual holes periodically on one of the harvesting layers and fill them with the same materials as the middle layer so that electrons and holes can be generated at these locations. This array of periodic cylindrical structures is called a photonic crystal. This structure helps to improve efficiency by 39% due to 3 benefits. First, it further shortens the harvesting distance for the electrons or holes that are generated inside the photonic crystal. Second, it concentrates light inside the middle layer so that the light can generate more electrons and holes. Third, there is an effect from the photonic crystal called the trapping effect that can trap light inside of the photonic crystal features so that light will generate even more electrons and holes. The clean energy produced by solar cells promises to change our lives for the better. They will help to reduce our greenhouse gas emissions and our impact on global temperature change, and they are one more building block on which we will support a vibrant future for many generations to come.